This video is a review of the slope-intercept form of a line. So in our course, we don't really cover the slope-intercept form of a line in full because we expect you to know it going in. But let's just talk about, a definition for it, and then, a couple examples just to make sure you know how to do it from review. So for the definition, the slope-intercept form of a line or a linear equation is given by, and it's really the form y equals mx plus b, which you should have heard of before, where y and x are going to stay y and x, right? They're part of the function actually, but where m is the slope and the point 0 comma b, so 0 comma whatever this constant is, 0 comma b is the y-intercept. So that's why it's called the slope-intercept form, because you can get the slope right away. It's whatever number is in front of x, not including the x, just the coefficient, the number in front of x. And then 0 comma whatever the constant b is the y-intercept. If this is minus b, then it'd be a negative here. So let's take a look at just two examples to make sure we understand how to use the y equals mx plus b form. So if I asked you to graph negative 8x plus 16y equals 32. The first thing we want to do if we want to get to the y equals mx plus b form is to solve for y here. Get y by itself on one side of the equation. And in order to do that, we first want to isolate the term that has y in it. So I have to move this negative 8x over to the other side somehow. So since this is negative 8x, to move it to the other side, what we're going to do is we're going to add 8x and add 8x. So I'm left with a positive 16y here, so I can just write that as 16y. If that was a negative, make sure you keep it negative. Is equal to, now 32 and 8x, they're not like terms, you can't combine them. So we want to write it in the mx plus b form, so I'm going to have the x's coming first and the constant last. So this will be a positive 8x, and then it's plus because this is a positive 32. If this had been negative 32, you put minus there. Alright, so positive 8x plus 32. And you can't combine them because they're not like terms, as we mentioned. So we're almost there. We have solve for y. So far we haven't gotten y by itself yet. To solve for y, what do? Y divide each side of this by 16, which really means you should divide each term by 16, right, to get y alone here. So 16's cancel. That's why we did it. And we get y equals. Now, if these reduce, you reduce them. If not, you have to leave them. 8 over 16. How does that reduce? Well, you can divide 8 out of each of these. So it reduces to 1 over 2, which is 1/2, right? So 1/2, and then x can be written in the numerator or right next to it. Typically, we're going to write it right next to it to follow our form, plus 32 divided by 16, which is 2. So we get y equals 1/2x plus 2. Now, make sure when you reduce this properly, right? It's 1/2, it's not 2 here, right? Dividing 8 out of each of these gives you a 1 over a 2 here. So 1/2x plus 2. Once you have this, now we're ready to just, find the y-intercept and the slope. The y-intercept, usually what you're going to use first, is always the point 0 comma. Remember the x value, in other words, for the y-intercept is always 0, because to be on the y-axis, the x value is 0. So it's 0 comma whatever b is, in this case 2. So the y-intercept is 0, 2. And our slope is whatever the coefficient of x is. What's in front of x? Well, 1/2. Well, if I have 1/2 in front of this, this gives you directions for your graph. So the way we work through this is first you want to plot the y-intercept always. So you always plot the point you know. So I'm going to plot the y-intercept. So 0, 2 would be 0, 1, 2 would be here. And then from the y-intercept, the slope tells you how to move around. Remember, slope represents change in y over change in x. So a positive 1 in the numerator tells you to move up 1, because remember the change in y would either be up or down because your y-axis runs up and down. So it's a positive 1, so you're telling you up 1. The denominator, right, for your slope is the change in x, so it's a positive 2. The positive x direction is to the right, so we say move to the right 2. So from our first point that we plotted, our y-intercept, right, 0, 2, we're going to go up 1 to the right 2. So make sure you're starting at that point. So from here, you're going to go up 1 to the right 2, and you can plot the next point. Now, if you want to be more accurate with this, you can keep doing that from each point. You go up 1 to the right 2, up 1 to the right 2. Now you could keep doing this. Remember, a line, you're going to draw a straight line through it. Arrows on the ends, it does go on forever in both sides. And so this is our line Either you can label it with the negative 8x plus 16y equals 32, or the y equals the 1/2 x, and then plus 2. Make sure that x is either in the numerator or right next to it. It's not in the denominator. So that's the line that we just graphed. Now if you do this in my math lab, you're only able to graph 2 points. So you would plot the y-intercept, then move over, go up 1 over 2, click and plot the next point, and that would give you the line. They don't put arrows on their lines, but you should be putting arrows on yours, because the lines do go on forever in both directions. Let's take a look at one more just to make sure that we have this down. So the next one we'll look at, if we said to graph 5x plus 7y equals 21. Now you might want to try this on your own first just to make sure that you know how to do it. So I'm going to pause the video here and try to complete this on your own. First thing, remember you want to get to the y equals mx plus b form, so I have to try to isolate the y term. To isolate the y term, I have to move the 5x. Since this is a positive 5x, how do I move it to the other side? Well, we subtract 5x, subtract 5x. So you go off with a positive 7y, because these cancel, and it's equal to, remember, these aren't like terms. You can't combine them together, right? They're not like terms because it has a variable of x. This doesn't. So we want to write the x's first and the constants last. So it's a negative 5x. I put minus 5x here. So positive 21, so I put plus 21. So the sign stays with the term, in other words, right? The negative stays with 5x, the positive 21, so it's a plus 21 there. And now to solve this for y, we're going to divide both sides by 7. Remember, that means divide every single term by 7. That's what keeps it balanced. And we end up with y equals. Now, negative 5 over 7, does that reduce? And the answer here is no. So it stays negative. A negative over a positive stays negative. 5 over 7 can stay 5 over 7. I'll write the x right next to it. Remember, it could be written in the numerator, but usually you write it right next to it. It can't be in the denominator. Plus 21 divided by 7 is plus 3. That simplifies, plus 3. So what are the pieces we know? Well, we know the y-intercept, which is always 0 for the x value, comma the y value, which is 3. So 0, comma 3 is a point in our graph. We know the slope, we've got negative 5/7. Now, if I write it as negative 5/7, there's two ways we can write this. The negative can be used in the numerator or it can be used in the denominator, but it can't be used in both. So we could write this as either negative 5 over 7, or you could write it as 5 over negative 7. We'll talk about what that means in a minute. So we've got the equation here. Now we're ready to graph it. So if I was to graph this, maybe I can just put the graph right here. The first thing we're going to do is we're going to plot the y-intercept, which is our 0, 3. So 0 is the x value, 1, 2, 3. So you're at 3 on the y-axis. Remember, y-intercept means where it crosses the y-axis. And then we're going to use our slope to move to the next point. Now remember, I said this negative in front either has to go on the numerator or denominator, but it can't go on both. And let's talk about what it means. A negative in the numerator, remember the slope is change in y over change in x. So a negative in the numerator would tell you the change in y is negative, means going down. So this would tell you to move down, right, 5 units. And a positive 7 in the denominator, that's the change in x value. Well, the x value being positive tells you that the x value is a positive changes to the right. So this would be right 7 units. So from the point I have, right, I can go down 1, 2, 3, 4, 5. Make sure you're counting the x as one of those, right? So 1, 2, 3, 4, 5. And then to the right, how many? 7. So 1, 2, 3, 4, 5, 6, 7. Now once you have these 2 points, you can graph your line going straight through them. And you're done. That's all you would have to do. If you would use the slope the opposite direction, right, 5 over negative 7, a positive 5 in the numerator, the change in y would be positive, so that would tell you to go up 5. A negative 7 in the denominator would tell you to go, right, that's a change in x, so the negative x direction would be to the left, so then you'd go left 7. Well, if I did the same thing now, starting at the y-intercept, if I use the other version of the slope, the negative in the denominator, going up 1, 2, 3, 4, 5, and then to the left, 1, 2, 3, 4, 5, 6, 7, you might notice they're on the same line. So you could use the slope either way, but the negative has to be chosen to be either in the numerator or denominator. it can't be in both, because a negative over a negative would make it positive. It would actually be the opposite slope. So we can draw our line through here. In my math lab, you can only plot 2 points, remember, so you only have to do it one way. I'm just showing you that you would have gotten the same answer either way. The point being, though, is, you know, the negative only can go in either the numerator or the denominator, not both. I typically use the negative in the numerator because then it just tells me to move down, and then the bottom number, the denominator, always tells me to move to the right, but it's your choice. So this would be the graph of, you could label it with the equation we had here or the original. I'll write the original on this one just so you see it. So this is 5x plus 7y equals 21. So just a quick review of graphing using the slope-intercept form. You know, it's going to be important that you know how to do this throughout math. And we do expect that you already have seen this before, so we're not spending too much time on it.